Hey all, so today I'll be doing the 2022 Methods Exam 1. So let's get started without further ado. Okay, so question number 1, the typical, we have y equals to this and we have to find the dy dx. Now, this is a 1-mark question, so directly writing the answer is acceptable. Okay, so let's do that. So let us say dy dx. Now we'll just have to use a product rule here. So let's differentiate the first term here. So that will give us 3e to the power of 2x plus, now we write 3x as it is, and now we differentiate the second term, which will give us 2 times e to the power of 2x. So combining this, we'll have 6x times e to the power of 2x. Okay, so find and simplify the rule of the derivative of f, where f of x is this. So this is a 2-marker question, so first we have to apply the quotient rule, and then I assume later when we do the question we'll have to simplify. So let us apply the quotient rule first. So derivative of x, f of x equals to negative e to the power of x, and differentiate cosine, will get sine, and then minus e to the power of x cosine of x divided by e to the power of 2x, right? Now this is the fine part done. Now we have to simplify it. So for simplifying, we take out e to the power of x as common factor. I'll just take out negative e to the power of x. So we'll have sine of x plus cosine of x, okay, divided by e to the power of 2x. So this would cancel out with this. So our final answer for this would be minus sine of x plus cosine of x divided by e to the power of x. Okay, so these are the 2 marks. So 1 mark for the final answer and the other one for actually showing the steps for simplifying. Now a heads up that all of the marking I'm telling you, like the marking scheme, is a suggested marking scheme. It may be or may not be accurate, so don't quote me on the marking scheme. Okay, that's just a disclaimer. Alright, so hopefully this question made sense. It's just a simple question from like every other question 1. So let's go on to the question 2. Alright, so find the rule for an antiderivative of g of x. Okay, so we just have to simply integrate this. So we'll have 3 over 2x minus 3 dx. Okay, so what I'm going to do, I'm going to take 3 out as common. So we'll have 1 on 2x minus 3 dx, right? And now I'm going to isolate this x over here. So I'm going to take 2 out as well. So 3 on 2. And we'll have 1 on x minus 3 on 2, right? Okay, so dx. Now we know that if we differentiate this, we'll just get a... if we integrate this, we'll get a log. So our final answer would be log base e of x minus 3 on 2 plus c. Okay, how many marks? That's 1 mark, so 1 mark for the answer. Alright, so evaluate all of this, where integral of this is 1 on 5 and this is 1 on 3. Okay, so let us start by expanding this integral out first. So then we'll have 0 to 1 2 times f of x squared, take away 3 f of x, right? And of course we have to add the brackets in. Okay, so as you can see now, it's just the fact that we have to separate the integral and solve it. So what we'll do is we'll separate the integral. So 0 to 1 2 f of x whole squared dx, take away integral of 0 to 1 3 f of x, right, dx. Okay, so then now we'll take the constants out, like this 2 and 3. So 2 times integral of that, so f of x squared dx, take away 3 times the integral from 0 to 1 f of x dx. Okay, now we already given this over here, that integral from 0 to 1 of f of x squared is 1 on 5. So we'll simply substitute that in. So 2 times 1 on 5, take away 3 times 1 on 3, right? Because integral of f of x from 0 to 1 is 1 on 3, and this is what we have here. So take away 3 times 1 on 3. Okay, so this will give us 2 on 5, take away 1. Okay, so that in final results would give us negative 3 on 5. Okay, so 3 marks. Okay, so 1 mark is definitely for the answer. The other 2 marks are maybe correctly splitting the integrals up and the working out for this question itself. Okay, so next question. So question 3, consider the system of equation. Determine the value of k for which the systems of equations above has an infinite number of solutions. So infinite number of solutions means what? That means the gradient and the y-intercept are the same. So just for the purpose of this question, I'm going to call this as equation 1, call this as equation 2. So what I'm going to do here, I'm going to first make y the subject for both of the equations so that we can, equate the gradient and y-intercept and then solve it. So let's start with equation 1 here. So minus 5y equals to 4 plus k, and then take away kx. So then we'll have y equals to, actually I'll take one step at a time, minus 4 plus k plus kx. So then y would finally be that, okay, plus kx all on 5. So that's for line number 1. Now let's see the equation 2. So we'll make y the subject again. So k plus 8y equals to minus 1 minus 3x. So y is equals to minus 1 minus 3x over k plus 8. Okay. Now, as I said earlier, we'll have to equate the gradients, because if it has infinite number of solutions, that means these two lines are exactly the same. So they will sit on top of each other basically. Okay, if you plot them, that is. Alright, so let's write that down. So same gradient. And now let us equate the gradient. So this over here will be the gradient for line number 1. So k on 5 equals to, and then this whole thing would be the gradient for line number 2. So minus 3 on k plus 8. Okay, now we'll just solve this for k. So k times k plus 8 equals to minus 15. So k squared plus 8k, I'll just say plus 15 is equals to 0. So now we have to factorize it. So we can say k plus 5 times k plus 3 equals to 0. So k equals to negative 5 and k equals to minus 3. Okay, so these are the solutions for when the gradient is the same. Now we'll have to do the same for the y-intercept. So we'll draw another line here and label it the same y-intercepts. Okay, so y-intercept for line 1 is this part. So let's note that down. So minus 4 will be minus 4 plus k divided by 5 equals to, all of this is the y-intercept for the second line. So minus 1 on k plus 8. So we can cancel out the minus sign. So 4 plus k on 5 is equals to 1 on k plus 1. Now again, we just solve for the value of k, like we did for the same gradients. Okay, so 4 plus k and k plus 8 equals to 5, right? So then we'll have k squared plus 4k plus 8k plus 32 equals to 5. So we'll have k squared plus 12k, and 32 minus 5 is 27, so plus 27 equals to 0. So we'll have k equals to, we'll factorize it. So k plus 27 and 12, so 9 times 3, so k plus 9 and k plus 3 equals to 0. So k equals to minus 9 and k equals to minus 3. Okay, now we can see that k equals to minus 3 is the common answer for the y-intercept and the gradient. So our final answer for this, so final answer is equals to k equal to minus 3. Okay, so hopefully this made sense. The logic wise, the question is quite simple. It's just the amount of calculations that's needed. Alright, so this is 3 marks. Well, 1 mark for the correct answer, then 1 mark for actually finding this here, and then 1 mark to show your understanding, or like this. Okay, so hopefully this made sense. All right, a card is drawn from a deck of red and blue cards. After verifying the color, the card is replaced, so it is with replacement in the deck. This is performed 4 times, so n is equals to 4, so the number of trials is going to be 4. Okay, each card has a probability of 1. Each card has a probability of 1 on 2 of being red and probability of 1 on 2 being blue. The color of any drawn card is independent of the color of any other drawn card. So let x be a random variable describing the number of blue cards drawn from the deck in any order. Complete the table below by giving the probability of each outcome. Okay. So let x be the random variable for describing the number of blue cards. So here we are finding probability, like this is probability that x equals to 0, this is probability that x equals to 1, so on and so forth. Okay, so we have to fill in the boxes here. So let us start by finding the probability of it being 4, because that's the easiest to calculate, and then we'll go from there. So probability of it being blue, red, oh, what am I doing? Blue. So blue, and blue, that is just 1 on 2 to the power of 4, right? So we'll have 1 on 16. Okay? Now we'll have to find the probability that x is equals to 3 and x equals to 1, which should be the same. Okay? The reason being the probabilities are the same. What I mean, I'll show you here. So let's say I want to find the probability that x is equals to 3. So there are 3 blue cards, right? So that will be probability that it's blue, and red, plus probability that blue, red, blue, plus probability that blue, red, blue, and probability that we got red, blue, and blue, right? So if I were to, do this manually, this is how I would do it. So we have four ways we can achieve the answer of getting 3 blues, because there are 4 trials. So 4 times the probability of success, which is 1 on 2 to the power of 3. So this is basically like applying the NCR formula, times by probability of failure, which is 1 on 2 to the power of 1. Okay? Now, if I were to simplify this, I'll get 4 times 1 on 8 times 1 on 2. So then our answer for this is 4 on 16. Okay? Hopefully that made sense. Now, why I was saying that probability of x equals to 1 is the same as x equals to 3, I'll show it to you now. So, let me just... Okay, that's okay, I'll erase everything. So probability of just having 1 blue will have red, blue, plus probability of red, blue, red, plus probability of red, blue, red, plus probability of blue, red, and red. Okay, so now even if I were to calculate probability that x equals to 1, which I'll do it now anyways, so what will happen here is we have 4 times probability of success, which is 1 on 2 to the power of 1, times by probability of failure, which is also 1 on 2 to the power of 3. So now, if I were to expand this out, wouldn't we get the same answer, right? So that's why I said it's going to be the same, because it is a fair, equally fair of being red and for being blue. So equal probability, and that's why the answer is going to be the same. So 4 on 16. Now, since it's a discrete, it's a PMF question basically, probability mass function. So let's check if everything adds up to 1. So 1 plus 4 is 5, 5 plus 6 is 11, 6 plus 4 is 15, plus 1 is 16. So 16 on 16 is 1, which is correct because all the probabilities add up to 1. Alright, hopefully this made sense. So next question, given that the first card drawn is blue, find the probability that exactly 2 of the next 3 cards drawn will be red. Okay, so what we are finding is probability exactly 2 of the next 3 cards are red given first is blue. So that is like basically finding probability of this whole thing here. Paste it down. Come on. Okay, it's acting up. No. Okay. I cannot. I'll just say 2 reds. 2 reds. Okay, now 2 reds is the same as exactly, this. I don't know why, but my iPad decided to act up. And then intersection of first is blue divided by probability of first being blue. So now you can simply solve it by using this information, or what I usually prefer to do, I draw a tree diagram so I have a visual in front of me, and that makes my life a lot more easier. Let's try and draw a tree diagram here. Okay, so we have red and blue. That's the first trial. I mean, we're only looking at blue first, so I don't think we have to worry about, drawing the tree diagram here. So we don't have to worry about that. So first is blue. So this is my second trial, red and blue. My third trial, red and blue. Okay, and this is my fourth trial. So red and blue, red and blue, red and blue, red and blue. We don't have to worry about the red here because we have to find given that first is blue. So we're only looking at this branch and onwards. So exactly 2 of the next 3 cards are red. So we'll have blue first, then red, and then blue again. So that's one of them. So that's one combo. Let's write it down. So probability of blue, red, red, and blue. That's done. And then now we can say probability that it's blue, and then red, and then blue, and then red again, right? So let's write that down. So probability of blue, and then red, and then blue, and then red again. And then the last one, which is going down this line over here. So blue, and then blue again, and then red, and then red. Okay, so plus probability of blue, blue, and red, right? Any other combinations? I don't believe. No. Okay. Now again, since the probabilities are the same, we would have 3 times 2 blues, so that's 1 on 2 to the power of 2, times 2 reds, so 1 on 2 to the power of 2. Okay? So we'll have 3 times 1 on 4 times 1 on 4, which is 3 on 16. So this part over here is 3 on 16. Okay? Now, what is the probability that it is blue in like the first ball or card? Yeah, first card is blue. What is the probability of that? Well, it's just going to be half because it could be red or it could be blue, and both of them have equal probabilities of getting selected. So divided by 1 on 2. and that will give you 3 on 16 times 2, which is 3 on 8. 3 on 8. Okay, so that is going to be your answer for this question. Hopefully this made sense. All right. So the deck is changed so that the probability of card being red is 2 on 3 and probability of card being blue is 1 on 3. Okay. Given that the first card is drawn blue, find the probability that exactly 2 of the next 3 cards will be red. So again, we are finding the same thing. So let's see if this tool works now. Copy. Okay, it still doesn't want to work. I don't know why. Paste. Okay, well, there you go. Okay, so it did work. All right. Funny. Okay, so we'll have the same solutions, same branches. The only thing that actually changed is the probabilities. Okay, so now if we want to have 2 reds and first is blue, so we have to see what is the probability of being blue. It's 1/3. And what's the probability of it being red? It's 2/3. So 2/3 and 1/3 again. Okay. So we'll have 1/3 times. Actually, it should be the same anyway because yeah, we have 2 blues and 2 reds, so we'll still have 3 times. What is the probability that there are 2 blue cards? So this is going to be 1 on 3, right? Because that's the probability of being blue, squared times 2 on 3 squared, right? Because that's the probability of being 2 red, right? So we want exactly 2 reds and two blues basically, given that first is blue. So that is the probability of that. And now if I were to expand this out, so 3 times 1 on 9 times 4 on 9, so we'll have 4 on 27. Okay, so probability of 2 reds intersecting first is blue, that probability is going to be 4 on 27, and then we are dividing that by probability of it being blue first. So what is the probability of it being blue here? It's just 1 on 3, right? So divided by 1 on 3. Now that will become 4 on 27 times 3, and that will give us 4 on 9. Okay, so that is going to be our answer for part C. Okay. So 1 mark for the answer and 1 mark for, I guess, the working out here. So that, and then calculating the probabilities, and then final answer. Okay. Hopefully all of this made sense. Okay. So question 5. So solve this for x. Okay. So 10 to the power of 3x minus 13 is equals to 10 to the power of 2, because that's again 100. So then we can say that 3x minus 13 is equals to 2, right? So we'll have x is equals 3x equals to 15, and then we'll have x is equals to 5. Okay, so 2 marks, 1 for that and 1 for that, I believe. Okay, so find the maximal domain of f where f of x is this. Now if I want log to be defined, this term inside the bracket must be greater than 0, because anything less than that and the log will be undefined. So all we have to do, all we have to do is to solve for this. So x squared minus 2x minus 3 greater than 0. So as long as this term, this quadratic expression inside log is greater than 0, our log will be defined, right? So let's solve for that. Now if I want to actually show you visually as to what this will look like, so let me just draw a parabola real quick. So since it's a positive parabola, it's going to look like this. Okay. Now we want that to be greater than 0. So what region of this graph is greater than 0? So it's going to be all of this here, all the way going to infinity, right? And then here, right? That's the part where the graph is greater than 0, correct? Okay. So hopefully this made sense. Now this is the intercepts, okay, that we still have to find, and of course all of this is also included. Okay, so let's factorize this now. So that will become, so minus 3 and minus 2, so that will be x minus 3 and x plus 1 is greater than 0. Okay, So now looking at this, our intercepts are -1 and 3. So what's our domain such that this parabola is greater than 0? Well, it's going to be x is less than -1 or x is greater than 3. Well, it's not going to be or and, it should be and. Okay, but to express it in a proper notation, we can write it like this. So x is basically from -infinity all the way to -1, right? Looking at this section here, including 3 all the way to +infinity, which is this section here. Now we can't include the x-intercept. Why is that? Because if we include the x-intercepts, this entire quadratic expression will become 0, and log 0 is not defined, so we can't include the x-intercepts. Okay, hopefully this made sense. So wow, 3 marks for this. I guess 1 mark for that, 1 mark for that, and 1 mark for that. So 3 marks for this is a bit shocking. I would expect it to be 2 marks, but okay. Alright, hopefully this made sense to you. Right, so question number 6. The graph of y equals to f of x, where f is between 0 and 2 pi, and f of x is shown below. On the axis above, on the axis above, draw the graph of y equals to g of x, where g of x is the reflection of f of x in the horizontal axis. So it's a reflection in the horizontal axis. So we are basically flipping the graph like this. So yeah, we're basically flipping the graph across this axis. So what will happen if I were to quickly just draw points? So rather than -1, if I were to flip it across x, it will become +1, right? So we'll just draw a bunch of dots to make our life easier. So here, this will go down all the way to here, right? And then this point over here will go up like so. Okay, hopefully this is, making a bit more sense now. Okay, and then this is going to be flipped up. So it's gonna be here, and then back down here, back up, like that, and like that. Okay, now we just have to simply connect the dots. So that, okay. This is not right. Okay, that will do. That, and finally this. So we can say that this is our g of x. Okay, we have reflected it across the horizontal axis, so that is all good. It's 2 marks. I guess 1 mark for the correct shapes and 1 mark for realizing the points method that basically I was talking about, that each point is matching, so we are not having our minimum peak here rather than having it in line with the maximum peak here and stuff like that. So yeah, okay, so find all values of k such that f of k is equals to 0 and k is between 0 and 2 pi. So f of k is equals to 2 sine of 2k minus 1, and that has to be 0. Okay, so then we'll have sine of 2k is equals to 1 on 2, right? Now carefully look at the domain. So for k, the domain is given to be 0 to 2 pi, right? So for 2k, what will happen to the domain? We have to multiply that by 2 as well. So this will become 0 to 4 pi. Oh, not, yeah, it will be square bracket, okay? So now what I'm going to do, I'm going to quickly draw a unit circle. Okay. And let's see. So sine is positive in which quadrants? It's positive in quadrants 1 and 2. So we'll have these 2 lines, so one from here and one from here. Okay? And this is the angle. So this will be like basically pi on 6, because sine inverse of half is pi on 6. Okay, now let's go from 0 to 4 pi. So starting from here 0, we'll go up that's one solution here. So what is that angle? So we'll have 2k is equals to pi on 6. That's first solution. And then we keep going. Oh, there we go. That's another solution. But we have to keep going. So now we have pi take away pi on 6, right? So that'll be pi take away pi on 6. Okay, that's two solutions done. Alright, now keep going. So we'll have that. We are back to 2 pi. So there's another solution here. So how do we write that? It will be 2 pi plus pi on 6, right? And then keep going. We are at 3 pi, but there is a solution here. So there will be 3 pi take away pi on 6. 3 pi take away pi on 6. So keep going, and we are at 4 pi. That's it. No more solutions. So 2k is equals to pi on 6. So what is pi minus pi on 6? It's going to be 5 pi on 6. 2 pi plus pi on 6 is going to be 13 pi on 6. Oh, not 12, 6. Okay, my brain jumped a bit forward. And 3 pi minus pi on 6 is going to be 17 pi on 6. So therefore, our k is equals to pi on 12, and 5 pi on 12, 13 pi on 12, and 17 pi on 12. Okay, so that's your answer. Oh, 3 marks. Okay, so so 1 mark, maybe 2 marks for getting all the values right, and then 1 mark for getting up to like this step over here, because after that it's just mathematics. So understanding comes here on this step. Okay, so I'm assuming 2 marks for the answers and 1 mark for the working out, I believe. Could be wrong. So yeah, okay, that's question 6. Oh, there's more. Okay, let h be h of x, where h is the same rule as f of x with a different domain. Okay, so the graph of y equals to h of x is translated a units up in the positive horizontal direction and b units in the positive vertical direction, so that it is mapped onto the graph of y equals to g of x, where a and b are between 0 and infinity. So in that case, let's go back up to the graph and see what we can do. So what do we have to find? Sorry. So find the value of b. So b is the positive vertical translation, basically. So h of x is basically f of x with a different domain. So what I'm going to do is I'm going to draw, like trace the graph of f of x, and then we can move it around and see how do we match it. Okay. Oh no, it has to be in one go. Okay. So like that. Okay, this is pretty good. Okay, now what are we finding? So find the value of b. So positive vertical translation. So we are basically matching the peak here with the peak here, like this level basically. Okay, so let's see, if I were to move, that's 1 and that's 2. So if I move 2 units up, I can basically get to the level of g of x, right? Okay, so b is equals to 2. Find the smallest value for a. So a is the positive translation in the x direction. Okay, so we can only move right. We can't move left because that's in the negative direction, but we have to move to the right. So currently we are here, and now how much to the right do I have to move to match the graph like this is what the question is asking us. Okay, so let's note down some of the points. Okay, now if I were to see, so basically let's say that we are looking at this point over here. So this is 0. Okay, now if I were to move this graph by some amount like that, I can basically get the point and the graph matching. So this point nav moved this much. How do I find that distance? So look here, this is pi, so that means this is pi on 2, right? And this is going to be 0. So 0 all the way to pi on 2. That's how much we have to move the graph to the right in order to match it, right? Okay, so in that case, let's write that down. So a equals to pi on 2. Okay? Hence or otherwise state the domain of h of x. Okay, so state the domain of h of x. This is where a lot of students actually went wrong, like in the exam. I'll tell you why. Because we had to change the domain of basically h, which is the same as f. Now most of the students actually wrote the domain would be from pi on 2 to 5 pi on 2, pi on 2 to 5 pi on 2. That is not right, because I'll show you why. We want it to exactly match the graph of g of x, right? So look at this portion over here. Like, this portion of the graph is not quite matching, right? So how do I change the graph, or how do I change the graph of the domain of f of x, so that when I apply the following, when I apply the following translations, it exactly matches this the graph of g of x. So what we actually needed was basically extending the graph like this, essentially, right? Because now what happens is, if I were to move like this, basically, now as you can see that we are currently matching the graph, except well, since we moved like this, right, now this region is not included. Okay, but the main thing is the graph here, the graph of h of x, which is the sky blue one, is matching the graph of g of x, right? So that means all we have to do, because this is perfectly overlapping, if that makes sense, right? So if I were to go back to where we were, so as you can see, currently the graph is perfectly matching what we have here, right? But if I was to go back to where we started like this, as you can see that this region over here doesn't match, and we have to change the domain such that it does match, right? Because we are changing the domain of h of x, which is what, f of x, basically. So we can't have it go from pi on 2 to 5 pi on 2. So that's why what we have to do is to move the graph pi on 2 to the left in order to match the actual g of x graph. Because now if we do not include this part over here of g of x, then we are fine, right? Because it perfectly overlaps, like as you can see here. Okay, and what is the distance between point this all the way to here? That's simply going to be pi on 2, right? Because as we calculated, it's pi on 2. So our domain is going from point this all the way to here. So that is basically, so if I write the value of if I write the domain of the actual thing, so that is k is from, domain of g, I mean, so domain of g is 0 to 2 pi, right? Domain of h would then be negative pi to 3 pi on 2, right? So that's the domain, because again, as I said, that it perfectly overlaps in this region if we move to the left. However, it wouldn't work if we move pi on 2 to the right. So that's that. And this point here is exactly between pi and 2 pi. So 2 pi plus pi divided by 2 is 3 pi on 2. So that's how we get the end coordinate. And this is just simply moving to the left by negative pi on 2. So moving to the left by pi on 2 units. So negative pi on 2 all the way to 3 pi on 2. Okay, that's how we obtain this answer. Yes, it was a bit tricky question, and a lot of students actually made a mistake. So yeah, but hopefully this makes sense to you guys, and all of these are just 1 mark, so just for the answers. Okay, right, so question number 7. a tile maker wants to make square tiles of 20 by 20 centimeter. The front surface of the tiles is to be painted with two different colors that meet the following conditions. Condition 1, each covers half the front surface of the tile. Each color covers the front surface of a tile, okay? Condition 2, the tiles can be lined up in a single horizontal row such that the colors form a continuous pattern. An example is shown below. Okay. So there are two types of tiles, type A and type B. So type A, the colors on the tiles are divided using the rule this, and the corners of each tile have a coordinates of this, okay, as shown below. Find the area of the front surface of the tile. Well, the area is just going to be 20 by 20, so it's going to be 20 times 20, which is equals to 400 centimeters squared. Find the value of A so that the type A meets condition 1. Okay. So if we look at type A, condition 1, so each covers, okay, so then if I were to say that this is my type A, right? Let's say that this is my type A. Okay. Now, if I were to draw a line here, now you can see that this area over here, which is filled, cancels out with this, right? So what do we basically have is just a rectangle, right? Just imagine that this area is gone and now it's filled up here. Okay, so all we have to focus is on this part over here, right? Now if I were to find the value of A such that the area is half, what would be our A? Well, what's the distance here? Because if the full distance is 20, what's half of it? It's going to be 10, right? And if I want half the area, of course it makes sense that I take half the height, right? The width is fine. It's just the height because we are cancelling out this area over here and putting it in here. So that's why I'm going to cancel this out. So now we have two sets of, now we have like a coordinate to work the value of A out. So what is our coordinate, you ask? It's going to be f of 0, which is here, is going to be 10, right? Because that's the graph. Like this is where the graph initiates. Okay, so let's do that. So, or the other way you can think about it, rather than, you know, writing all the equations down, what you can do is just look at the graph, right? So this graph is responsible for maintaining the half the area coverage basically. And this graph, if it's only covering half the area, that means it's moved up by h by 2 units. Now h is the total height of the tile, so that's going to be 20 by 2. So A basically is going to be end up being 10 anyway. So what we can say though is f of 0 equals to 10. So we have, what is our function? We have 4 sine of 0 plus A equals to 10. So sine 0 is 0, so our A is going to be 10. Okay? So that's the understanding of that. Okay, hopefully that made sense. Alright, so type B tiles is an example. Type B tiles, an example of which is shown below, are divided using the rule this. So show that type B tile meets the condition 1. So condition 1 again is, you know, covering half the area basically. So in that case, so we know that area of a tile is equals to 400 centimeters squared. So half the area is equals to 200 centimeters squared, which is simply divided by 2. And what we have to do is to show that if we integrate this from 0 to 20, we will basically get 200. Okay? Because all we have to do is to show that the area under this graph is half the actual area of the tile, which is 400 divided by 2, so 200. Okay, so let's integrate this. So we'll have 0 to 20 integral of g of x, which is negative 1 on 100 x cubed plus 3 on 10x squared minus 2x plus 10 dx. Now of course we have to add the brackets because we are, you know, adding and subtracting, not dividing and multiplying. So let's just integrate this now. So we'll have 1 on 400 x to the power of 4 plus x cubed on 10, take away x squared plus 10x, right, from 0 all the way to 20. So let's substitute 20 in. So negative 1 on 400 times by 20, so 20 to the power of 4. So we can say it's 400 times 400, right? It's 20 squared. So 20 squared times 20 squared. So I'm going to say it's 400 times 400. The reason why I chose that, so that we can easily cancel out when we are subtracting, when we are simplifying, I mean. Okay, plus 20 to the power of 3 is 400 times 20, which is 8,000 on 10, minus 20 squared, which is 400, plus 10 times 20, which is 200. Take away, everything would just become 0. So 0 plus 0 minus 0 plus 0. Okay? So this will cancel out. We'll have minus 400 plus 800 minus 400 plus 200. So that will mean that minus 400 and minus 400 will cancel out with positive 800, leaving us with 200, which is equal to half the surface covered. Hence, condition 1 is met. Condition 1 is met. Okay? Determine the endpoints of f of x and g of x on each tile. Hence, use these values to confirm that type A and type B tiles can be placed in any orders to produce a continuous pattern in order to meet condition 2. Okay. So first we have to find the endpoints of f of x and g of x on each tile. Okay. So basically, if the endpoints are the same for f of x and g of x, that means it can be placed in any order. So let's say that we are putting type A first. Okay. So type A is the tile which involves a sine function, just that one. Okay. And type B is this over here. Okay, so let's say we are putting type A first. So that would mean that f of 20, which is the ending of the tile, has to be equals to g of 0, right? Because g of 0 is the starting point of the next tile with a different pattern and different function. So let's find out what f of 20 is. So it's 4 sine of, I keep forgetting the function, so it's pi x, so 20 pi on 10. So 20 pi on 10 plus 10. So this and this would cancel out. So sine of 2 pi again is going to be 0, so which is equals to just 10. And let's calculate g of 0 now, because f of 20, that's the last point on the tile, has to be the same as the g of 0, which is the starting of the next tile if you are placing type A tile first. So g of 0 is just simply 10, because everything just becomes 0, so 10. So there you go, that works out pretty well because the endpoints are the same. Now let's do the other one. So type B first. So if I'm putting type B first, that means that g of 20 must match up with f of 0, right? Because g of 20, if tile B is first, and then the next tile will be f function, and the endpoints, so that g of 20 and f of 0 must be the same, so that it forms a continuous pattern, right? So let's calculate what g of 20 is. Okay, so that will be minus 1 on 100 times 20 to the power of 3, which is 8,000. Okay, plus 3 on 10 times 400. Take away 2 times 20, which is 40, and plus 10. Okay, so that and that would cancel out, so 80. So minus 80, so this and this would cancel out to 40, plus 120, minus 40, plus 10. So minus 80 and minus 40 would add up to minus 120, so all of this would cancel out, leaving us with 10. and then f of 0, which is 4 sine of 0 plus 10, which is simply going to be 10. Oh, not a, 10. So as you can see that all the endpoints are equal now, right? So we can say in our last sentence that since f of 0 equals to g of 0 equals to f of 20 equals to g of 20, tiles can be placed in any order. Okay, hopefully this made sense. Right, so next page. Okay, so question number 8. So part of the graph is shown below. The rule A of k is this, okay, gives the area bounded by the graph of f and the horizontal axis and the line k x equals to k. State the value of a pi on 3. So we are just simply substituting in. So a of pi on 3 is equals to pi on 3 times by sine, yep, pi on 3. That is equals to pi on 3 times root 3 on 2, which is pi root 3 on 6. Okay? So evaluate f of pi on 3. Now, we are given that this rule over here gives the area under the graph, basically. So basically what that means is if we integrate f of x, we will get area of x, right? Now I want to find f of x. So what do? We differentiate the area function to get f, right? So let's do that. Okay, so f of k is equals to a dash of k, right? And let's calculate that. So area differentiated, we just have to apply the product rule. So we'll differentiate first term, that will just give us sine k, and plus leave the first term as it is. Now differentiate the sine, so we'll get cosine. So k cosine of k. So that over here is going to be our f of k. So f of k is equals to sine k plus k cosine of k. Okay, so our f of pi on 3 would be sine pi on 3 plus pi on 3 cosine of pi on 3. So that would be root 3 on 2 plus pi on 3 times cosine of pi on 3 is going to be 1 on 2. So that is pi on 6, pi on 6. So that should be our f of pi on 3. Okay. So 1 mark just for the answer, 2 marks giving this, and 1 for that. Okay. So hopefully this makes sense. Alright, so let's move on to the next question. So consider the average value of the function f over the interval 0 to k, where k is between 0 and 2. Find the value of k that results in the maximum average value. Okay, so average value, we know the formula. What is the formula? So 1 on b minus a, going from a to b, f of x dx, right? So in our context, I'm going to change it up. So in our context, we have k minus 0, so that is just going to be k, 1 on k. Integrate from 0 to k. And if I want to find the average value of f, I have to integrate f of x dx. Now, what do we know about integrating f of x? We already know that area function is given. So if we integrate f of x, we'll get the area under the graph, right? So area function is already given. As you can see that a of k gives the area bounded by f. Okay, so integration is solved. So all we have to do is 1 on k. Now integrate that, we'll get k of sine k, right? So that and that will cancel out. So our average value is equals to sine of k. And we have to find the maximum of that, and k is between this range. So there are 2 ways of finding maximum value of k. I'll go through both. I'll do the method I like first, personally. So let's draw a unit circle, okay? Alright, so we have the unit circle. Now our k value can be from 0 and 2. So what is the region? So we know that pi is going to be 3.14, right? So it has to be, the pi is here. So our region has to be somewhere here. Wow, that's a good line. Okay, our region has to be this region over here, right? That's the region we are looking at on the unit circle, correct? It can't be all the way to here because, well, that would exceed the domain of k. So we can't let that happen. So let's say that this is our 2, k equals to 2, right? And this is our k-axis, this is our whatever, y-axis, okay? And we want to find the average, like the maximum value of sine k. Now what do we know about unit circle? We know that any point on the unit circle can be denoted by cosine theta and sine theta, right? Or in this context, we can say cosine of k and sine of k. Cosine of k and sine of k, right? Now, y coordinate is sine of k, which is what we have here. Now, what is the maximum y coordinate in this shaded region over here? It's going to be here, right? And what's the y coordinate there? It's going to be 0 and 1. So y coordinate there is going to be 1. So the maximum average value, occurs when k equals to, so what would the value of k be to give sine equals to 1? Pi on 2, right? If we have sine pi on 2, that gives us a value of 1. So k has to be pi on 2. Okay, now that's one method that you can do. Nothing wrong with it. So that's just using pure visualization. And I prefer that because, you know, it's better to have a visual. It gives you clearer understanding of what's happening. And now let's go through the second method, which is the typical, you know, take the derivative and set it equals to 0 to get the maximum. So let us do that now. So average value function is this over here. Now, if I were to differentiate sine, we'll get cosine. So dk of sine k is equals to cosine of k, right? And set that equals to 0. So cosine of k equals to 0. What do we get? K equals to, so when is cosine 0? So basically, again, if I were to refer to this circle over here, in this shaded region, when will x coordinate ever be 0? Right here, right? Because that's the y-intercept, correct? So in that case, we want to get a value of k such that the x coordinate becomes 0. So cosine of what is going to be 0? Cosine of pi on 2 is 0, right? So pi on 2. So both methods are quite similar, except one method you need to do one more additional step, which is to differentiate the average value function. Nothing wrong with it. It's just, you know, doing it by graph is better, just for a better visualization. Okay, but feel free to use any method that you want. I personally prefer the graphing method much better because I love having visuals in front of me. Okay, it makes my life a lot more easier. Okay, I think that's it. Yeah, so that's it for 2022 exam 1 for methods. So hopefully you learned from this video, and yeah, have a good day, and I'll see you in the next video. Bye bye.